Well, we're back in the machine shop for another weekly buffer. A couple of weeks ago, we had a conversation about adding robotic automation to our vertical mills to solve some issues that we're facing, but we've been looking at the numbers and it's not gonna be enough. I think the problem runs a lot deeper, and if we want things to run smoothly in our shop, we're gonna have to take decisive action now for later down the line as the company continues to grow. Almost all of our production centers around our Grove 5-axis machining center. This is the heart of our machine shop and manufacturing power, but we're already pushing up against the limits of the machine. When we recently had another machine quoted, the lead time was over a year out. And as we continue to grow and see more Sentinel DAC orders coming in, we're faced with a backlog that's simply unmanageable. The most efficient solution is to just start telling customers that your order will be 3 months out, or 6 months out, or maybe even 9 months out. But that's not really how we've operated as a company, and as consumers ourselves, we don't really enjoy those extra long lead times. So we want to look at MSB and find ways that we can address this issue and expedite production for our customers. So the robotic solution that we decided to add to our vertical mills, that's something that we're going to do right away, and that's going to help alleviate some of the immediate needs. But with over a year-long production on a new Grove 5-axis machine, we have to start planning now for that eventuality. So just today, we actually signed a new contract to purchase another Grove 5-axis machine and pallet pool station. It's a really big commitment for us, but signing the contract is the easy part. The decision has been made, but now the real work begins. I want to show you kind of the scale of how big this machine is. So let's bring the camera around and get some perspective on the footprint required for a Grove 350A. I'm going to be standing right here. This is the center of our machine shop, and the machine is all the way out to my placement. So right now it takes up over a quarter of the floor space in our shop. As I was mentioning, the fit of this machine is literally at the limits of this building. So you can see here where we've actually inserted the machine around the building trusses. It barely fits, but we do know that it fits, so we are very confident that the second machine will be able to be accommodated in the same space. So with limited shop space, we need to be very mindful of every machine we bring into the building, because every machine we bring in is another machine we can't buy. So by adding the same exact machine one time over, we're not actually adding any capability to what we can do, but we are increasing our production capacity. And for now, production capacity is more important than ever, especially with the Sentinel DAC and the high level of machining that's required to make those chassis. But alongside the production capacity, we get a few other key benefits. So you'll notice here we have two VF2s side by side. These are two identical machines. Having these machines be identical allows us to move jobs between the two machines. If one machine breaks down, we can do the same work on the other machine. If one machine is busy with a long job, we can stagger another product on the other machine. It allows a lot of flexibility between jobs. And with how we've made the Grove the center of our manufacturing, if it broke down for a long period of time, we would have a lot of issues with production and be at risk of not being able to deliver products for a long period. So by adding a second machine in this space, we give ourselves the redundancy of having two machines. We can bring the same G code and the same work holding to each machine running simultaneously. Then we can prioritize certain jobs to double the spindle. And if we run into any issues with the machine, we have a backup, and production can continue as planned without any major delays to our shipping times. So to add a second Grove machine, we're gonna have to relay out our entire shop and start from the ground up with new layouts for our CNC machines. The plan is going to be to put the second machine here in this corner of the machine shop. So basically we'll be adding a second instance of the same machine here in the same position in the room. So we know it fits well, and this orientation works, and the clearances work, so we know it'll also fit over here. So the constraint on where the second Grove goes is actually quite easy, because it's really only going to be able to fit in one spot. But to accommodate it, we now have to move this machine, our lathe. And then we're also going to have to move all of our shelving and storage. So the plan is we're going to rearrange our shop over here in this corner to increase the machine density. So we'll be taking our VF2s and staggering them to create extra space on the end of this row. So we'll take this VF2, move it out, and then move it all the way to the wall here. But now we have air compressors in the way. So we're gonna take the air compressors and swing them back around and have them along the back wall behind the VF2. And now the second VF2 is going to be able to slide this way, and then we'll bring the lathe and put it right on the end here. So this wall will now have 3 of the Haas machines lined up in a very tight condensed pattern. That should be very efficient for the placement and shop space. But speaking of air compressors, we now run up to another issue with adding the second Grobe. The Grobe machine and its pallet pool uses a lot of compressed air. So our current system is set up to have a main, very high efficiency air compressor. This provides most of the air, maybe 90% of the air for the shop. And then we have a second backup machine with an air reservoir, which provides a buffer and a backup if we ever use too much air at once. But with the second Grobe, we're absolutely gonna need more air capacity. So what we'll probably do is replace our older inefficient machine with another of these new VSC machines, but then we'll have to add an air reservoir as a buffer. So if both machines are using a lot of air at the same time, you don't want the air compressors to lose pressure because it'll trigger a power off of the machines. So what we're gonna do is add a large air reservoir tank that will be able to supply and provide air at those peak moments to take the load off of the air compressors and keep everything running smoothly. But the growing problems don't stop there. So we have a couple other things we have to address. The power consumption of this machine is vast. The spindle alone runs over 40 horsepower. So for us to add a second machine, we have to have the power capacity. And it's not just about adding breakers, it's about how much power consumption we can take from the transformers at the street. So now we need to do a power study on how much power consumption our facility does as a whole, how much power consumption this machine does, and compare and make sure we're able to add this machine without causing any issues. We'll also have to add 480 volt transformers for the Grobe machine and its pallet pool and add those to our incoming power. And yet there is still even more work to do. So right here, you'll notice this pad on the ground. So this here is a pad that we have to put under a machine like this to provide stability for the spindle and the machining area. So for the second machine, we'll have to cut out another hole in the slab and install one of these stability slabs. So this is isolated from the rest of the ground so that we don't disrupt the alignment when we're driving the forklift by or moving other equipment. And it's about 30 inches thick of solid concrete underneath the machine. So as soon as we lay out where the second Grobe is gonna go, we'll have to mark off this new space, have some contractors come in, cut out the floor and install a new slab. So this is a lot of unknowns. It's a lot of risk. It's a very expensive machine purchase. The purchase order is for over $1.2 million. This is a really big investment for a company like us. And as I just pointed out, there's a lot of problems that we have to solve and solutions we have to come up with. So that's just gonna balloon that price even further. With that said, we're still being very careful about this purchase. So we put in a 6-month clause on the purchase contract with the machine supplier where we have a window to start checking a lot of these variables and make sure we're actually able to accommodate the machine. In the meantime, they're gonna start the production, ordering the materials and getting it started so that our lead time window doesn't continue to grow. I am sure we'll be sharing some more updates in future videos of how this process comes along. So please like and subscribe if you'd like to see what it takes to install one of these kinds of machines and automation centers in a machine shop like ours. This is a really daunting project for me. It's gonna take a lot of energy and resources over the next year to prepare for this machine, but I think it's a great example of the commitment we have to in-house manufacturing and producing the very highest quality parts. Thanks for watching, and we'll catch you in the next video.